Hello student, we learn about in wave optics chapter a new concept. What is meant by wavefront? Wavefront. Suppose S be the source of light. Consider that S be the source of light and it emits light in different directions. In all directions. Light emits in all directions. At time t, the point reaches at point A. Here, source of light emits waves or emit light in all possible direction. Then, at time t is equal to, at the instant of time t, wave reaches up to point A. In the same time, wave reaches up to point B, C and D. At time t, the waves reaches at points A, B, C, D. These A, B, C, D points lie in same phase. A, B, C, D points lie in same phase. Therefore, such a points, locus of all such a points, locus means set of point. Such a points then form a wavefront. Locus of all such a points are in same phase. Same phase means consider that wave SA reaches the at point A to crest. Here again K, crest, 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 or trough, 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 trough. Therefore, the points are in the same phase. All ABCD points are in the same phase. It covers the same distance at time t. That points are equidistant from the source of light. That points means SA is equal to SB is equal to SC is equal to SD. That points, that distance is equal to, that distance is calculated by using t is equal to time, distance is equal to speed into time. Therefore, speed means light speed, velocity of light. It is denoted by c. Therefore, distance is equal to c into t. Therefore, total distance SA is equal to speed into time means c into t. That distance covered CT means they are equidistant from source of light. Such a formation of locus of all such a points are known as wavefront. Wavefront, its definition is locus of all such a point where light travel in same phase. Light travel in same phase at a given time is known as wavefront. Wavefront is again repeat its definition. Locus of all such a points where light travel in same phase at a given time is known as wavefront. Wavefront are of two types, three types mainly, but cylindrical wavefront, spherical wavefront, plane wavefront and cylindrical wavefront. These are the three types. But in our syllabus, only two types are given, types of wavefront. First one is spherical wavefront and plane wavefront. We study only spherical wavefront and plane wavefront. What is the difference in between them? Spherical wavefront and plane wavefront. Where the source of light is at finite distance, then form a spherical wavefront. Source of light is at a fixed distance or finite distance, then form a spherical wavefront. And plane wavefront, source of light or point of source at infinite distance. For example, sun. Sun is the source of light. It emits light in all directions. Therefore, plane wavefront occurs from sun. And spherical wavefront, the any focus is at finite distance or known distance, then obtain a spherical wavefront. Wavefront, locus of all such points where light travel in same phase. Light travel in same phase at a given time is known as wavefront. We study about how to form a spherical wavefront. Hello, we study first about Hess Principle. Hess stated that formation of wavefront, every point on wavefront acts as a secondary source of light and sending light in all possible direction. Means, suppose S be the source of light, it emits light in all possible direction. The point reaches at time t, it covers a distance ct. Therefore, such a locus of points are known as wavefront. Because of source is at finite distance, then spherical wavefront is formed. Then spherical wavefront at point A, B, C, these points are formed on wavefront. It acts as a every point on wavefront. Every point on the wavefront acts as a secondary source of light. Every point on the wavefront acts as a secondary source of light, sending light in all possible direction. All possible direction. Secondary source or that wavefront, it again produces light in all direction. Therefore, the wavefront, every point on wavefront acts as a secondary source of light. Every point on the wavefront acts as a secondary source of light and it emits light in all possible direction. Means at point A, B, C, these points emit light in all possible direction. These are the first assumption for Hess Principle. Second Hess Principle is light always travel in forward direction. Light always travel in forward direction. Therefore, light waves are in but wavefront. First postulate or first principle, first statement of the principle is light in all possible direction. That statement gives light possible in all directions because of the backward light sending from point A, B, C, backward light direction are ineffective. Light sent in backward direction are ineffective. Therefore, light travels in always forward direction. Light travels in forward direction. These are the two assumptions for Hess Principle. Every point on the wavefront acts as a secondary source and the secondary source sending light in all possible direction. But that statement which gives the perfection of that second statement, light always travel in forward direction but light waves are in backward direction are ineffective. That waves are ineffective in the backward direction but it always sending from the wavefront in forward direction. These are the assumptions for Hess Principle or it noted that the 2 points it based on the construction of spherical wavefront and plane wavefront. Hello student, we study about construction of spherical wavefront. Construction of spherical wavefront. First consider that S is a source is at finite distance. Construction of spherical wavefront is the first condition, source is at finite distance. Therefore, S is at finite distance, and then at time t is equal to 0 means primary wavefront, such a locus of all points at time t is equal to 0, then the wavefront is obtained A, B, C at point A, B, C acts as a secondary source, because of every point acts on a wavefront acts as a secondary source of light according to Hess principle. Therefore, A, B, C acts as a secondary source of light and it emits light in all possible directions. Therefore, A, B, C send a light in all possible direction. Hence, light in backward direction are ineffective. Therefore, only CT distance at time t is equal to, at the time instant at time t is equal to the semicircle or the hemicircle are drawn, and at point A dash, B dash, C dash reaches at the point A dash, B dash, C dash, it again form a secondary wavefront. That ABC is known as primary wavefront. Primary wavefront. And A dash, B dash, C dash is known as secondary wavefront. Primary wavefront and secondary wavefront form at complete a distance. CT is the distance travelled. Therefore, A dash, B dash, C dash are the secondary wavefront. Then every point acts on the A dash, B dash, C dash wavefront acts as again secondary source. It again emits light in all possible direction. Therefore, we get again hemisphere here. And draw next wavefront. Therefore, such a wavefronts are formed at the instant time t is equal to 1 second, t is equal to 2 seconds. Such a formation is known as spherical wavefront. Therefore, spherical wavefront's first condition is source is at finite distance, and spherical wavefront is formed when source of light is at finite distance, first condition. Second condition, A, B, C is the primary wavefront. At time t is equal to 0. At time t is equal to 0. And A, B, C acts as a secondary sources. And A, B, C acts as secondary sources. Then it again emit light in all possible direction. When at point A dash it cover a distance CT, therefore at time t is equal to, at any instant time t is equal to A dash, B dash, C dash is formed. Therefore, that is known as secondary wavefront. Primary wavefront and secondary wavefront. At time t is equal to 0, primary wavefront is obtained, and at instant time t is equal to, secondary wavefront is formed. Therefore, construction of spherical wavefront, ABC is the primary wavefront, and third point is A dash, B dash, C dash is the new wavefront. New wavefront, or it is also known as secondary wavefront. That is secondary wavefront. Secondary wavefront. It again produces it acts as again secondary sources of light. It again produces or emits lights in all possible directions. Then we obtain the third wavefront, then fourth wavefront, like as the Wi-Fi signal is denoted by that sign. Means A, B, C, all such points on the same wavefront acts as in the same phase. They are in the same phase. A, B, C are in same phase. But here A produces again next source A dash, B dash, C dash. At time t is equal to 0, t is equal to 1, t is equal to 2. At the same system where A dash, A double dash, that are not in same phase, but on the A, B, C, on the same wavefront, points A, B, C are in the same phase. A dash, B dash, C dash are in the same phase. Therefore, construction of spherical wavefront, the first condition is the source of light is at finite distance. And second one is ABC is formed at the primary wavefront, and ABC or every point on the primary wavefront acts as a secondary source. And A dash, B dash, C dash is a new wavefront is known as secondary wavefront. It again acts as a secondary sources. S is the primary source. S is the primary source. It produces the wavefront. That wavefront is known as primary wavefront. And ABC on the point of primary wavefront acts, ABC acts as a secondary source of light. Hence, S is the source of light. First wavefront ABC means primary wavefront at time t is equal to 0, and A dash, B dash, C dash is the new wavefront, secondary wavefront at time t is at any time instant t. That is the construction of spherical wavefront. Now we see about in plane wavefront.